Okay, so in this lesson we're going to be solving systems by graphing. So we're going to be taking two lines and we're going to solve it to see where they connect at. So first, if I'm drawing three possibilities of what could happen if I graph two lines on one graph. Let's draw our three graphs. Okay, so if I wanted them to connect once, there's that type of possibility, so that would be one solution. Another possibility is if they're parallel, then we're going to have no solution because they never cross each other. That means our last solution possible is if we have two lines on top of each other, in which we're going to call it INF, which is infinite solutions, because they cross an infinite number of times because there's multiple points that they have in common. So how many times do these cross? Well, it looks like it crosses right here, so it's crossing once. And if it was shifted over a little bit, my graph's a little bit off, it looks like they're crossing at 2, 2. So my answer would be either one solution, or if I'm asking for a specific solution, it would be 2, 2. How many times do these cross? Well, it doesn't look like they cross any, so our answer for this one's going to be no solution. This one, it's crossing an infinite number of times because they're both sitting on the same line. So this one's going to be called INF. So here are the different possibilities for exactly one solution, no solution, or infinite number of solutions. So you can go ahead and pause that if you'd like to write it down, but I'm going to move on. So what is the point of intersection? So let's graph this one in pink first. So we're going to start at 2. And then we're going to go, since it's a negative, we can have only one negative, so we can go down one to the right one, or we can go up one to the left one. And then, because we're doing this, we're going to have to keep the line going to see where they cross it. So we're going to just keep going up one, over one, up one, over one, up one, over one, and we're going to keep doing it till we get to the edge. And then we're also going to go down one, over one, so we're going to keep going in this area. Then we're going to connect our dots. Try to get them to connect though. And now we're going to do our other line. So this one. So we're going to start down at -2 this time. And then we're going to go up 3. 1, 2, 3, over 1. Well, we see that they connect there, so we can go ahead and draw our line. So my solution then would be 1, 1, because that's where they're connecting at. Now if I wanted to check my answer, I would plug this in for my x and for my y, and again over here for my x and my y to make sure that that's correct. Okay. So now we're going to try this one. So we're going to graph this one in red first. So we're going to go up 1. Then we're going to go down 1 to the right 3. Down 1 to the right 3. Down 1 to the right 3. Now the other one's up 1 to the left 3 because only one of them can be negative. Up 1 to the left 3. Up 1 to the left 3. Then we're going to connect our dots. And now we're going to do the other one. So it's down 1, down 1 to the right 3 again, down 1 to the right 3, down 1 to the right 3, up 1 to the left 3, up 1 to the left 3, and so on and so forth. So it looks like these are parallel lines. So there's going to be, our solution is going to be no solution. And the way that we can tell, just by looking at the equation, that they're going to be parallel is because these slopes are the exact same, but these are different. My y-intercepts are different, so they're going to be sitting on different y lines, but since our slopes are the same, we know that they're going to be parallel. If I would have had the same equation, plus 1. If I would have had these two equations, we would have known that they would have been sitting on top of each other, so it would have been infinite. So these are two different ways that you can tell if you're going to have no solution or an infinite number of solutions. Okay, so we're going to start at 2 for this one. And we're going to go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. We're just going to keep doing that point. And then we're also going down to the left 1. And if we keep going, it's going to look like that. And now let's do our other one. So it's down 2. And then we're going to go up 3, 1, 2, 3, to the right 1. And then up 1, 2, 3, to the right 1. So it looks like they're crossing right there. So our point for this one is 2, 4. And again, if I wanted to test this, since this is my x and this is my y, going from my x, going from my y, and you do it for both equations to make sure that they equal each other. Okay, so let's do this one. We're going to go down 3, then we're going to go down 3, 1, 2, 3, to the right 1, because it's the same thing as negative 3 over 1. So we're going to go down 3, 1, 2, 3, to the right 1. Or we can go up 3, 1, 2, 3, to the left 1. 1, 2, 3, left 1. 1, 2, 3, left 1. 1, 2, 3, left 1. And then we're going to connect our dots. And we're going to do this one now. So we're going to go up 2. We're going to go up 2, 1, 2 over 1, up 2 over 1, up 2 over 1. Also down 2 to the left 1, down 2 to the left 1. Looks like they're connecting there, so let's draw our line. So that is actually going to be negative 1, 0. Again, I suggest you plugging these points in and checking your answers, because I have a lot of people that think that it is 0, negative 1, and then they're going to write down the wrong answer. But you can easily check to make sure you have the right answer if you plug them into my equations. Okay, so let's do this first one. When we have y equals 2x, well, we know the slope is 2 because it's always in front of x. Let's add a plus 0 onto the end. So if we do that, then we're starting at 0, 0. We're going to go up 2 to the right 1, 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 up 2 to the right 1. Also down 2 to the left 1, down 2 to the left 1, and so on. And then we're going to connect our dots. And now let's draw the other one. So we're going to start up 1. We're going to go down 1 to the right 2, and it looks like that's where they're actually crossing at. So for this, I'm going to say 1 solution, because otherwise it's going to be a weird fraction. Okay, x equals negative 3 and y equals 5. Well, if we do x equals, remember the person has to die, so they have to fall off a cliff, so we know this is going to be up and down. And then y equals 5, we think, why am I doing this? Why am I cross-country skiing? So it's going to be like this. So if we do the x equals negative 3, we have to go to where x equals negative 3. Well, my x-axis, this is where x equals negative 3. And then my line has to be, well, straighter than that, but it has to be up and down. My y equals 5, we have to go where my y is set at 5. So we're going on my y-axis, and it has to be left or right. So there's my point of intersection. It looks like it's negative 3, positive 5.